Here are the answers for the day one warm-up. Draw structural formulas for each molecular compound. In the directions, I've indicated that these are molecular compounds, but if it didn't say that, it's important that you know how to figure out whether a compound is ionic or molecular. Question A has 2 chlorine atoms. Those are nonmetals. Question B, hydrogens and oxygens. Those are nonmetals. Question C, nitrogen and hydrogen. Those are nonmetals. Notice that none of these have any metal in them. These are not combinations of ions. So that's why these are molecular compounds. You can draw a structural formula for these by using dashed lines to show covalent bonds, which are pairs of shared electrons, and using dots to represent unshared electrons. A key principle that's used to draw a structural formula is to follow the octet rule. Atoms besides hydrogen are most stable when they have 8 valence electrons. So one strategy in drawing a structural formula is to make sure that every atom, again except for hydrogen, ends up with 8 electrons around it. And those electrons could be a combination of dots and dashed lines. So let's do a molecule of chlorine, which has 2 chlorine atoms. Chlorine is in group 7A. So each chlorine atom has 7 valence electrons. There are 2 chlorine atoms in the molecule, so we have 14 valence electrons to work with. We want to create a drawing that uses 14 electrons, yet each atom ends up with 8 electrons around it, a complete octet. The first thing that we can do is put a shared pair of electrons between them by drawing a dashed line representing a covalent bond. That single dashed line is 2 electrons. Now, working in pairs, let's put the additional electrons around the atoms. These pairs of dots are called unshared electrons. Here is the structural formula for a chlorine molecule. I have shown 14 valence electrons. Some of them are shown as dots, and 2 of them are shown as the dashed line, but there are 14 of them there. And I followed the octet rule, meaning that each atom is surrounded by 8 electrons. Again, some of the electrons are dots, and that dashed line represents 2 electrons. Now question B, H2O. Each hydrogen atom contributes 1 valence electron to the molecule. There are 2 hydrogens, and there is 1 oxygen. Oxygen is in group 6A, so it has 6 valence electrons. There are 8 valence electrons to work with when drawing this molecule. Another principle that you follow when drawing molecules is to make molecules look symmetric. So with 2 hydrogens and 1 oxygen, the oxygen most likely goes in the center, and the hydrogen atoms go on each side. That creates a symmetrical looking molecule. Again, start by connecting them with a single dashed line, single covalent bonds. Each of the dashed lines is actually 2 dots. So by drawing those 2 lines, I've used up 4 dots. There are 4 left. Remember that hydrogen is the atom that's an exception to the octet rule. Hydrogen only needs to end up with 2 dots next to it to be a stable atom. By putting that dashed line next to the H, that's the 2 dots. So don't go around and put any more dots on the H's. Put the 4 dots on the O in pairs, 2 above, 2 below. This structural formula has 8 valence electrons shown through a combination of using the dashed lines and the dots, and the central atom, the oxygen, is surrounded by 8 electrons, which fits the octet rule. Question C. This is ammonia. It has 1 nitrogen atom and 3 hydrogens. Nitrogen is in group 5A, so it contributes 5 valence electrons. The 3 hydrogens contribute 3 more electrons. We have 8 electrons to play with when we draw this. Follow the principle about making it look symmetric. So nitrogen in the middle, a hydrogen on this side, a hydrogen on this side, and then the third H, either put it above or below, that does not matter. Connect the hydrogens to the nitrogen using single covalent bonds. Those 3 dashed lines are 6 of our electrons. We have 2 left to use, and they'll go on top of the nitrogen. Each hydrogen ended up with 2 electrons next to it, and the nitrogen is surrounded by 8 electrons, which fits the octet rule.